Okay, so here's the next problem. I've gone ahead and already written out the velocity equation. And so we're going to do C relative to A, where A isn't moving. Okay, so we need to find out omega CD and alpha CD. So it's going to be this. I'm going to assume both of those are going counterclockwise. And we'll see how lucky I am. If they come out positive or not. So I'm going to take counterclockwise for omega CD and alpha CD. Okay, so you always start these problems with a velocity problem. And so let's write down everything we know. We know that the velocity of C, so C is spinning around D if you look at that rod, since I assumed it's counterclockwise, I've got it going down with a value of R is 0.5 and omega is unknown, omega CD. Okay. Omega CD. Let me write that in there. So omega CD. Okay, that will equal the velocity of A, which is a pin, not moving, so that's nice. Okay, plus C spinning around A. And so we're given that the omega of bar AB is 5 radians per second and a arm of 1 meter. So draw that in dotted. So it's going to be going this way. Okay, so perpendicular to that arm, which is 30 degrees below horizontal, so that makes this 60 degrees. And that value again is going to be R1 times omega 5. Okay, and then we have C relative to A sliding. I'm gonna guess it's going downhill this time. We'll see if I guess right. So that'll be V C relative to A, and that's going down that arm, which is at 30 degrees below horizontal. Okay, and so again, since I learned from my previous experience that the best coordinates to take are along this arm, so I'm going to call that X prime, and this way Y prime. And so we got to break the components of V sub C, break down V sub C into its components going that way and this way. Okay, and so let's see, so that will be 0.5 times sine 30 degrees, so that will be 0.25 omega CD. And let me get the cosine of 30 times 0.5. I'll be right back. Okay, so that comes out to be 0.433 omega CD. Okay, so I just took sine of 30 degrees times 0.5 omega and cosine of 30 degrees times 0.5 omega. Okay, so now we're ready to take the components. So let's solve this. So before we solve this, I went ahead and highlighted the unknowns. And then I noticed that in the x direction, there's a WCD component, omega CD, and a VC relative to A. But in the y direction, the only unknown is that omega C relative to D. So what I'm going to do, I'm just going to solve the y direction first. It doesn't matter if you did x first, but I'm just being lazy so I can get an answer right away. So I'm going to take up and to the right as positive, so that 0.433 omega CD is going actually down and to the left, so that's negative. Okay, this C spinning around A is going in the right direction, and I somehow erased what the value was. So it was omega of 5 and an R of 1, so it's 1 times 5. Okay, so equals 5 going in that direction, and this doesn't have a component. So we can solve for omega CD right away, and let me do that and come back. So omega CD comes out to negative 11.55 radians per second. So once again, I've guessed wrong. So this means it's going counterclockwise. And now that I look at it, if you're spinning bar AB clockwise up, bar CD is going, AB going counterclockwise, that point C is moving up, which means DC is going clockwise. So that's right. Okay, so about 11.55 radians per second that way. Okay, so now we're ready to do the X component, the X prime component. Okay, so I'm taking downhill as positive, so 0.25 omega CD, and I'm going to put in negative 11.55 for that. Okay, equals, so that 1 times 5 does not have a component in the X direction, and we get VC relative to A. So we get, let me plug in the numbers, 0.25 times minus 11.55 equals V of C relative to A. And that gives V of C relative to A equals minus 2.60 meters per second. So again, I guessed wrong. So I guessed going downhill, so this is actually going uphill. Okay, so let me write down everything we've got so far. So we have omega CD is 11.55 radians per second clockwise, and VC relative to A in the XYZ is 2.6 meters per second going that way. Okay, so now on to the acceleration.